Hi, welcome back to the shop. Yesterday I visited a friend, and he has a super neat and nice foundry setup where he's doing aluminum castings in sand. And I was there to cast parts for a single cylinder steam engine, for a model steam engine. The design and the patterns were made by him. Normally he sells these part kits, and I'll link down in the description to his webpage. And he allowed me to do my own castings of his patterns. So, and he also gave me the set of drawings that come with the castings. So I took some video footage and some pictures down at his shop and his foundry where we did the castings. I did the mold making and he did the casting, as he's used to it. He's used to the process of the casting and the melting of the aluminum, but the mold making was down to me. So I will show you some footage of that, and then we will take a look at the actual castings. Okay, here we start to make the mold for the A-frame. There are the two halves of the mold box and the split pattern for the A-frame. One side of the A-frame goes down into one half of the mold. Then it gets covered with the oil-bound sand. The first layer of sand gets sieved, and I just took a look if everything's alright, and some more sieving until the whole model is covered with sand, and then you just shovel on more sand. And then it's just a matter of compressing and stomping the sand to make for a solid mold. And he has this nice pneumatic sand stomper. That's a professional sand stomper for foundries. And now I'm just filling up the mold with sand, getting everything filled up, compressing it again, and again using the pneumatic tool. And from time to time I also use a piece of wood to compress it, and now I'm scraping off the remaining sand to make the mold half flat on one side. Okay, first side done. Cleaning off the table, flipping it around, and you can see the split model. Now I will take the other half of the split model, put it on, get some powder on there, and using a fine brush, which is in fact a makeup brush, to cover the model evenly. This helps as a mold release to get the model out later, and also to separate the two halves. And then it's again just a matter of filling the mold with sand. Again, the first layer gets sieved, and then I'm shoveling on the remaining sand. And I compress it on the corners with a piece of wood. And I use the pneumatic tool again. The pneumatic tool needs a lot of air, it's loud, and it's fast. And then we just fill up the mold until it's completely full. There we needed another bag of sand. And yes, I'm wearing gloves because the used oil sand is super dirty. You get black hands within about 30 seconds. And yeah, compressing the upper layer, working in a kind of a spiral pattern, adding some more sand, press it, and scraping off the remaining sand with a piece of sheet metal. Now I use a hammer, knocking the two halves of the mold to release them from each other. The halves of the mold are aligned with pins, but by hammering them you can break this, the bond between the two molds, and I just separated them. Now you can see that the split halves are still in the sand, and I will do some cleanup with the brush where some sand got in areas where it shouldn't, and just do some cosmetic work, hence the cosmetic brush. And now I'm going to punch the sprue into the sand, and also we add a feeder, a reservoir for the molten aluminum, as there is a big mass of material in this mold. Okay, I'm using a copper pipe to cut the sprue. And when you knock the copper pipe with something, the sand comes out. And now I'm using a small spatula to cut the aluminum reservoir. This will fill up with aluminum and feed the actual casting with fresh aluminum when it cools down, so you don't get shrinkage. And now I'm cutting the gates from the sprue to the feeder, and from the feeder to the actual model. Yeah, there I cut the gate to the model. I make sure that there is no loose sand in the model, and oh yeah, now I'm measuring the position of the feeder, and I will cut in the other mold half, which will be the lower half, a sump. In the sump will all the dirt from the first entry of the aluminum in the mold be collected, so you don't get any of the oxide, slag and stuff into your actual model. It will stay in this sump, and by compressing it with the finger I make sure there is no loose sand in it that might mess up anything. I do that to all the gates, the feeder, and also to the sprue itself. Yeah. Now we'll use the air gun to clean out the remaining loose sand from the mold, and I will also flip it up and blow in there. And there is the sprue from the other side. I also dig a small funnel to make the casting process easier. So he has not to aim that precise with the aluminum, with the liquid aluminum. And also I cut another sump up in there, so that collects also some of the first wave of dirt. There you can see the sump. And yeah, that's the mold making itself, and I think yeah, now I'm releasing the models out of the mold. The model is tapped. It's drilled and tapped with 6mm threads, and he has some screws that can be screwed in and act as a handle when to release the model. I knocked the model slightly with a hammer to release it from the sand, sideways and on top, so it moves slightly and it breaks the bond to the sand. I do this always. Some people don't like to do it. I prefer it, so it gives some wiggle room when you pull out the model. Here. And now I lift out the model, which released very well. It went out of the sand pretty good. And I didn't do much damage to the actual mold. Yeah, the release of the model is always a bit, yeah, you need to be careful, but yeah, that's good. Just pull it out and be fine. There you go. And I'm pleased. Okay, there we go with the second model. Again, turning in the screws. Of course, by tapping the model in the mold, you slightly change the dimension of it. You move it side to side, you compress the sand in some areas, and yes, you change the dimensions, but it's maybe a few tenths of a millimeter, so it's not super critical. And oh yeah, this went this one went even better than the first one. And make sure that you pull the model out very straight. Don't tip it to one side. Now I'm doing some cosmetic work. I'm burnishing the edges slightly with my finger, and my head is in the way so you can't see it. I'm burnishing the edges slightly where there is loose sand or something like that that might fall into the mold. And also I'm looking for loose sand in the sprue and the feeder. And compressed air is your friend when you do this. And you have to be careful not to blow in with 6 bar of pressure, or you might damage the mold. And I have my hand there not to blow the sand all over in his shop. And I found some loose sand in there, so I went over with the finger and burnished some of it. Now I'm standing up the lower half of the mold, also blowing out the loose sand. Make sure everything is all right. And now we will put the mold halves back together. Yeah, now we will put it back together. Make sure you put it back on the right direction. Look for the alignment pin and just drop it on carefully. There you go. That's the mold. And here we have the molten aluminum freshly out of the oven in a graphite crucible. Here he is getting rid of the slag and did the casting. He just filled up the mold with the molten aluminum. This is the A-frame. There we go again. A full crucible and filling the mold. And another one. Also note the full protection equipment, the fireproof suit, the visor. He has the proper shoes and gloves. Okay, there you can see the oven. The furnace blow burner is firing directly into the chamber of the oven. And there we go for another run of casting. Scooping off the slag that would interfere with the castings, that would give a bad surface and might give inclusions in the aluminum. And there we go. Filling the molds with aluminum. And when he fills the second mold, you will see on the right side that there is smoke. When I built this mold, I had the pattern a bit close to the side of the mold box, and there some aluminum got out of the mold. But it still went okay. And now it's up to open the molds and get the castings out there. The castings and the sand are still pretty hot, so you have to be careful not to burn yourself with one or the other. And there is the cylinder and some of the smaller parts, and we're just releasing them from the sand. And really be careful not to get the hot sand on your bare skin. That hurts. And then it's on the time to get the sand out of the mold boxes, and later it will be reprocessed in the sand muller. So, okay, that's it. That's the casting process. Back into the shop. Okay, we're back in my shop, and as you saw, it was a whole lot of fun. His furnace setup is super neat. It works like a charm. It's just working. He's using a oil burner from a house furnace, and he's running it on diesel. And you just flip a switch, and the whole furnace starts up, does its starting procedure, and then fires up the burner. And then you wait 15-20 minutes, and you can do your casting. But now we will take a look at the actual castings that I did there, or we did there. Okay, here we have the set of castings for the steam engine. We have this part. This is the base plate. It's hollow on the back side, and when we did the casting, there was almost we did a row of molds, and this was the last one in the row, and there was almost not enough aluminum left in the crucible, and for that reason the mold didn't fill up all the way, and that's why there is a big radii here. And it's also about 5mm shorter than it should be, but it doesn't matter. This is just the base plate. My machine will be a bit lower than everybody else's that has these castings. We'll machine this side flat, flip it around, and machine the mounting surfaces for the A-frame and the crankshaft. And we have the A-frame, which is a really nice part. The patterns he made are just gorgeous. They have a super nice finish. They're easy to release out of the mold sand, and they are just super nice, and you can see that the castings are also very neat. The surface finish is incredible. He's using a oil-bound sand, and that really shows every detail in the finished casting. And we have the cylinder. We did this with a core, with a sand core. There is still part of the core in there, and I will break this out later. This can just be removed with a screwdriver. And we have the valve cover. That's just a cover plate that goes on here. And we have the cap of the cylinder which goes on here. And we have the two bearing blocks and the bearing caps. And we'll machine all these parts. And we have also to make some parts from stock material, like small flanges. The crankshaft will be machined, and some more parts. So let's see how we tackle these castings. Castings are always a bit it's different, not harder but different. Castings have draft to them. That means these sides are not square, they have an angle to them, and you need that so you can release them from the mold. Otherwise, if you have a 90-degree square, you have a hard time to get them out of the mold sand or the oil-bound sand. So that's the first challenge, and also you have to decide where to reference off, as it's a raw casting. You don't have any references. You have to do a rough layout and then shift it so it's nice and even. Same with parts like this A-frame. You have to decide where to start, and with the A-frame I think first we're going to machine the lower surfaces and then bore out the guide for the con rod, and also machine the upper flange here. The bearing blocks are pretty straightforward. It's just surfacing the lower bottom, surfacing the upper, drilling, screwing the cap on, and then drilling and reaming or boring the opening for the bearings itself. There will be brass bearings, plain brass bearings in there. The cylinder will get no liner. There will be a brass piston running in the aluminum, and that will hold up fine. I was thinking about doing a liner, a steel liner, but I don't think it's necessary. This machine will not run for hundreds and hundreds of hours. So, yeah. Okay, here we have the cylinder still with the sand core in it, and we drop the pieces after casting in water to get rid of the oil, the burned oil sand, but the sand core in it is still in there, and this is a job to be pulled out with a screwdriver. When you're working with castings, you want to get rid of all the sand, because the sand on one hand will ruin your cutters, and on the other hand it's really bad for the guideways of your machines. It's like emery. This can ruin your day. I will rinse the remaining sand off under with water. So okay, here we are back with the remaining sand washed out, and we have a pretty nice bore in the cylinder. Of course, this will bore open to the right diameter of the cylinder later, but for now this is a pretty nice casting. Not too bad of a surface finish. There is some shrinkage here and here, but that's because of this bulk of material here. When there is a lot of material in a casting, when it's cooling down, it's pulling the material in as it shrinks. And there are ways to accommodate this, but this is just really a lot of material, and the shrinkage is not too bad. Okay, we will start with the base of the steam engine, and this is pretty straightforward. We have to surface down the rear side. On this surface it will sit later. And we'll flip it around, strap clamp it down to the table, and surface these 4 pads, drill them and tap them. Some of them are 3mm tapped holes and some are 2mm tapped holes. So that might get interesting. But first we have to get rid of these 2 guys. This is part of the sprue where the aluminum ran into the casting. Okay, I clamped it carefully in the benchwise and I will just hacksaw these lugs away. Okay. Now we can do some proper machining on this part, as these 2 things are away. Okay, we're over at the milling machine and I fiddled out a setup. It's way simpler than I thought. The reference surfaces are these 4 pads. These have to be somewhat square to the bottom surface, and these are still raw cast surfaces, but when you take something more or less straight, you can see they are pretty precise, and also in that direction. And I just put 2 parallels in my vise, and I will rest these 2 pads on the parallels. And the draft on the side of the part is steep enough so I can still clamp on that and it's not going to move on me. Of course I have to push the part down onto the parallels while I clamp, because I can't really knock this down onto the parallels when I clamp it. And I have to use some brass shims so the sharp edges of the vise jaws don't dig into the material. And I have a big roll of this 1/10mm brass shim stock that I have always around. And I use this always on the milling machine for shimming and protecting surfaces. I use it also on the lathe when I have to chuck up critical surfaces in the 3-jaw chuck. And now I can test with the parallels. Of course I can move them. The part is not really sucked down onto the vise, but there is little play down there. And I'm pretty confident that this setup will hold up to the machining. And we only have to run a small end mill around the edges to clean it up. And the end mill we are going to use is a high-speed steel high helix cutter for aluminum. This is one of the few occasions that I still use high-speed steel cutters when I machine aluminum, and these high-speed steel ones with the high helix, especially designed for aluminum, they are really nice. If you don't use them on steel, they hold up forever and they are not super expensive. I think one of these is 15 or 20 bucks. So that's quite reasonable, and you can resharpen them yourself on the front surfaces, or you can send them out to have them resharpened on the diameter. Okay, let's run this at about 1000 RPM and skim the outer boundary of this piece and hope that nothing else flies out of the vise. But I'm pretty confident in this setup. And also we are not going to take a super heavy cut. And it helps if you switch on the machine's main power. Okay, as you see, I have most of the perimeter of the part cleaned up. There are some bits left where the end mill was not wide enough, so I have to take another walk around it, but overall worked out great. And the material, the cast aluminum machine's super nice. It gives a nice short chip as long as you add some, at least a bit of lubrication. There is a high content of silicone in this aluminum, and that tends to gall and almost smear on your cutter, and also it dulls the cutter pretty fast, or faster as normal aluminum. Especially the free cutting aluminum is, you can run an end mill forever in that stuff, but this will dull an end mill. Okay, I was just checking the surface heights of these pads we will machine later, and the accuracy in this castings is really good, and that's by the really good patterns he made for these parts. And these two surfaces are within plus 0.02 of a millimeter and minus 0.1 of a millimeter. So these are virtually at one level, and these two pads need to be 5 millimeter higher, and they are within plus let's see, plus 15 and plus 47 hundredths of a millimeter, and that's really good. We will machine the lower surfaces, or will we? No, we will first cut the upper surfaces, and then we will machine the lower surfaces to be exactly 5 millimeters below these pads. And also what I noticed is, when I get a dial indicator on the corner of the piece, and in a second I will bring down the camera, when I try to tip the part, there is almost no needle movement on the dial indicator. Let's try this corner. Yeah, it is maybe 0.005 of a millimeter, but that's really good. The part didn't warp on the machining, and that's a good sign, so we can proceed with the machining of these surfaces. And these are virtually the most important surfaces on this base, as they align everything to each other. Okay, I clamped down the base plate with 4 clamps onto the machine table. I have brass shims everywhere to protect the surface of the casting, and I have a small fly cutter in the machine spindle. And now we're going to surface these upper pads, then we will surface the lower pads, then we'll take a measurement and machine these to their final height. We need a distance of 5 millimeters between these, a height difference of 5 millimeters. Now, yeah, it's also distance. So let's see. Okay, I swung the camera around so you can see better what's happening there. First I'm going to touch off, and then we'll take a light cut and see how it goes. That's 1000 RPM there. Okay, let's take a skin pass. Okay, this first pass worked out pretty well. It cleaned up the whole surface of the front pad, which was the lower one, and of course the The back pad, which was 5/10 of a millimeter higher in some spots, also cleaned up. Yeah, I don't think that there is much more to do. I will take another very fine pass to give him a nice surface. This is kind of rough right now. Also we're going to add some lubrication, which also helps. Okay, that's our two pads, the higher pads, which will hold the A-frame, and the surface finish is pretty good. Now we can machine the lower pads. Yeah, it helps if you engage the gears. Okay, we got both of the pads surfaced and also should be on the right height on these. Remember, this needs to be 5 millimeters, and I have my tutorial dial test indicator here with the depth measuring gauge, and it's set to 0. And when we drop it onto the step here, we are 1/100th of a millimeter low. Yeah, that's okay. That's I think that's in the tolerances for a steam engine. And back here, sorry, you can. Oh, I just can turn it around so you can see it at least a bit. And back here we have also 1/100th of a millimeter low. So I'm guessing that both pads are at the same height to these two, but 1/100th of a millimeter low, and that's fine. Okay, I blued up the surfaces so you can see better what's going on. I have a spotting drill in there, and I'm going to center all the positions for the threaded holes in the base where the pillar blocks and the A-frames will be bolted to. Not at 200 RPM. Okay, now we have all the positions spot drilled. I was just running off the numbers on the DRO and taking a small and drilled a small spot there. So these are going to be M2. These are also going to M2 threads. And these are M3. That means metric thread, 3 millimeter nominal diameter. These are 2 millimeter threads. The tap drill for M3 is 2.5 millimeters, and the tap thread for an M2 is 1.6. But I have to look it up. I'm not 100% sure about this. Okay, let's take a look in our good old reference book. And we have metric ISO thread M2, drill diameter 1.6 millimeters. Okay, I had that right in mind, so that's good. Okay, I drilled all the tap holes, and right now I'm threading the 3 millimeter threads. Power tapping. So let's go. I did already these two, and now we're going for the other two on this side. Get some cutting oil on there and did I mention how much I love power tapping? I think I did. I think I mention this every time I do some tapping on the machine, how much I love it. It's just a great process, it's so reliable. There we go. That's the 3 millimeter threads, and now we need to tap the 2 millimeter threads with this tiny tap. I never power tapped the 2 millimeter thread, but it seems that it works pretty good. Yeah, I will do the remaining ones off camera. I think that's it for the first episode. We saw how the castings were made, we machined the first one, so I think that's enough for this time. Thank you for watching and see you next time.